Section 7.5 is on parts of similar triangles. So we have special segments in similar triangles, and we have three theorems that relate to that. Remember when we talked about special segments, I believe it was back in chapter 5, we talked about perpendicular bisectors, angle bisectors, medians, and altitudes. And we're going to be talking about three of those today, and I'll review what each one is. So our first theorem says if two triangles are similar, so it's given the triangle ABC is similar to triangle EFG, then the lengths of their corresponding altitudes are proportional to the lengths of the corresponding sides. So in the first triangle here, segment CD is an altitude. Recall that an altitude is a segment that goes from a vertex perpendicular to the opposite side. So CD is an altitude of the first triangle, GH is an altitude of the second triangle. This theorem says that if these two triangles are similar to each other, then altitude over altitude equals side over side. So CD over GH is equal to AB over EF. You could also write it, and you'll get the same cross product, CD over AB is equal to GH over EF. So if two triangles are similar, then their altitudes are proportional to corresponding sides. Second theorem says if two triangles are similar, then the lengths of the corresponding angle bisectors are proportional to the lengths of the corresponding sides. So here we have two similar triangles. ABC is similar to EFG, and here I have an angle bisector AD. And remember, that's an angle bisector because it cuts angle A into two congruent parts. An angle bisector EH cuts angle E into two congruent angles. So this theorem says that if these two triangles are similar to each other, then the length of the angle bisector, so AD over EH, so the proportion between the angle bisectors, is equal to the proportion of corresponding sides. So angle bisector over angle bisector over angle bisector equals side over side. Although you could do it that way too. Angle bisector over side equals angle bisector over side. And I just chose AB and EF. It could be any of the sides because they're all going to be proportional to each other. If two triangles are similar, then the lengths of the corresponding medians are proportional to the lengths of the corresponding sides. Recall from chapter 5 that a median is a segment that goes from a vertex to the midpoint of the opposite side. So we start at C, go down to D, and D is the midpoint of side AB. The same thing here too. GH is a median because H is the midpoint of EF. Okay, so CD and GH are medians. So if triangle ABC is similar to triangle EFG, then median over median equals side over side. So CD over GH equals AB over EF, or CD over AB equals GH over EF. And I only chose AB and EF because those were convenient. I could choose any other corresponding sides. So median over left equals median over left. And the triangle angle bisector theorem. Notice the difference with this theorem and the previous ones is those all had two triangles in them. This one has just one triangle that actually has an angle bisector in it. And it says an angle bisector in a triangle, so that would be AD here because that bisects angle A, separates the opposite side into two segments that are proportional to the lengths of the other two sides. So AD is an angle bisector, so it bisects big angle A, and then it creates two segments over here, BD and DC. So you need to look at those two segments there. And those are proportional to the sides that they're next to. So AB over BD is equal to AC over CD. So side over segment equals a side over a segment. Or you could also say the side AB over a side AC is equal to segment over segment. So if I'm going to do the top side and the bottom side, then I need to do the upper segment and the lower segment. So let's take a look at a bunch of examples here. Each pair of triangles is similar, and in each case we need to find x. So we have triangle ABC and triangle EFG. We know they're similar to each other, and here we have DB and here we have HF. So DB and HF, since they go from a vertex to the midpoint of the opposite side, they are medians. So the length of the median is proportional to a side, or a set part of a side. So I can say 12 over x, or let's do it this way. Let's do 12 over 8. So median over median is equal to x over 5, a part of a side. I could do it the other way also. I could say 12 over x, so median over side, is equal to 8 over 5. And you'll notice when we do the cross product, we get the same thing. So 8x equals 60, or x is equal to 7.5. And notice when I do the cross product here, I'm going to get the same thing. 8x equals 60. So I can do median over median equals side over side, or median over side equals median over side. I could even do side over median, side over median. In any of those cases, x is equal to 7.5. Here again we have two triangles, and in this case we have altitudes because CD goes from a vertex and it is perpendicular to the opposite side, as does GH. So CD and GH are altitudes. And the lengths of the altitudes are proportional to corresponding sides. So I can say 16 over x, so altitude over altitude equals 20 over 15. I could also say, if I wanted to do 20 over 16, so side over altitude has to equal side over altitude, and actually there's probably other ways I could say that too. Just make sure that what you're doing kind of makes sense. So let's do the cross product here. So 20x equals 16 times 15, which is 240, or x is equal to 12. And you'll notice you'll get the same cross product if we do that one. So the altitudes, proportion of the altitudes, or the ratio of the altitudes is equal to the ratio of corresponding sides. Here we have some angle bisectors. You'll notice that segment CD here cuts in half big angle C, as does segment GH cuts in half big angle G. So CD and GH are angle bisectors. Okay, so again we can set up a proportion. X over 8, bisector over bisector, equals side over side, or I could say 15 over x equals 12 over 8, side over bisector equals side over bisector. 12x is equal to 120, or x is equal to 10. And notice that you would get the same product, cross product over here. 12x equals 15 times 8. And our last example, notice we only have one triangle in this example. And we do have AD, which is an angle bisector. Okay, and we know that if there is an angle bisector, it cuts the opposite side into pieces that are proportional to the sides. So we know that AC is 15 and AB is 9, CD is X, and CB is 32, but what I really need to know is how long DB is. So DB is going to be the whole thing, which is 32, minus this piece right here. So DB is actually 32 minus X. Okay, the whole thing minus the other part. Now I can set up a proportion. I can say, actually a lot of different ways I could say this, 15 over x. Okay, so side over the segment equals 9 over 32 minus x. So side over segment equals side over segment. I could also say 15 over 9 equals x over 32 minus x. Any of those would work. So doing the cross product, 9x equals 480 minus 15x. 24x equals 480, or x equals 20. So what this section is saying is that 3 of those 4 special segments that we talked about back in chapter 5 also can create proportions within a triangle, in similar triangles. And again, like I said in the last section, kind of go with your gut. If setting it up makes sense, it's probably going to work.